All right, solving for variables. This is the first video in a series of 24 videos solving 24 equations. They're ascending in order from least difficult to more difficult. And we're just going to go through them. I've got a checklist on the right here. Very simple. Looking at how many terms we have, how many variables there are, and is it an equality? Now I'm going to go from the bottom to the top because every single equation in this series will be an equality, meaning there will be an equal sign. Every single equation will have a one variable. I'm going to write what variable that is, x, and the next will tell me how many terms are in my equation. Terms are separated by operators. So I have one operator and two sides. So I have 1, 2, 3. So we'll write 3 terms. And the reason I like to do that is because it breaks the equation down into its individual parts and gives you a better idea of what the outcome and the process of how to solve it will begin. In order to isolate this x here, let's think what is happening around it. On the left side, there's 2 terms, and my x is on the left side, which means something's happening around it. It's a -1. So to get rid of that -1, let's just go 1. And then +1 on the right. That's gone. That's just gone. That's pretty cool. Next, you have 4x equals 11 plus 1 is 12. Now you have a coefficient in x. That's the only thing that's applying to x, equals 12. Let's get rid of this coefficient. Well, it's multiplying. So we're going to divide through. And simplify the fraction out. You are left with the answer. X is equal to 3. And that's the first one. Pretty easy. Now just checking. You should always check your answer. Plug in 3 where x is. So you're going to substitute this 3 for your x. 4 times 3 minus 1 equals 11. 4 times 3 is 12. Minus 1 does in fact equal 11. So that's correct.
Okay, now we're going to talk about the application of real life scenarios onto equations. So where do these equations come from? Because I think a disconnect between doing math equations, isolating the variable, solving for the variable, ending up with a value that you plug in is completely disconnected from real life scenarios. So we're going to kind of dig into this equation and apply a real life scenario of kind of where you would get something that looks like this and how to use it to your advantage, really. So you have a total of 11 on one side, and you're going to have to assign different variables and you're going to have to assign different things to different values and also something to your variable. So I think x in this equation is going to represent the number of contracts that a company has, or that a company needs to find out, actually, because it's an unknown. Unknown. The value of x is unknown. The numbers around it they're going to represent workers or units of labor. So to start, I would start with a total of 11. I would look at like what that represents. I'm going to draw 11 units of labor. Six. 11. So I'll draw above or below 11. And that is equal to 4 people into an unknown number of contracts minus 1 person. That seems confusing, right? Yes. So remember, we can rearrange these. If we add 1 to both sides, that's going to bring your total to 12, aka 12 workers. 1 didn't materialize. That is the total number of workers you have. However, this -1, just get that back for a second, represents a worker who has now disappeared. They've gone on leave, they've left the company, no one knows. Well, people do know, but they're not asking because they got contracts to do. And so to solve for x, I'm going to have 4 people. 4 people multiplied into x number of contracts minus 1. And when you solve it down, x is equal to 3. So you'll have 3 contracts. And of course, the bigger contract is to the lesser people. So this is what it represents. So you have 4 people per contract, minus 1, that's Steve, equals 11 people in total on your team. Now, this is good because say you wanted to figure out how many workers, how many contracts you had when you apply the same number of people to the contract, but your team has grown. So instead of 11, your total number of people is 47. You have 47 people in the company. I'm not going to draw that. But to solve for x, we just do the same thing. You add 1, divide by 4. 4x equals 48. Divided by 4, divided by 4. X being the number of contracts. You'll have 12 contracts in total if you apply 4 people per contract less 1 person for the entire team. And from a business perspective, say this is marketing, this is HR, and this is strategy or upper management. That's just a representation of like how you would apply these to actual real life scenarios. So the 4x minus 1 equals 11 represents 4 people per one contract with one team working with one less person because the person's left.